You know how sometimes the world looks a little weird through a glass of water? Or maybe how a window can distort the view outside just a tiny bit? Well, we're about to dive into the fascinating physics behind those everyday moments. We are talking about refraction.
You've absolutely seen this, right? You put a perfectly straight straw into your drink, and boom, it suddenly looks like it's bent, or maybe even snapped in two, right at the water's surface. It's such a classic optical illusion. But what is actually going on with the light that's tricking our eyes like that?
And there it is, refraction. It's just one word, but this single concept explains so much. It's not just the bent straw, it's why swimming pools always look shallower than they really are, and it's even how raindrops can split sunlight into a perfect rainbow. It's a fundamental rule of light that has some truly beautiful consequences.
Okay, so let's tackle that bent straw mystery head-on. To do that, we first need to get a really solid handle on what refraction actually is.
So, what is it exactly? Well, at its heart, refraction is the bending of light. Simple enough. But the key detail isn't just that it bends, it's when it bends. This only happens at the exact moment light crosses from one substance, or what scientists call a medium, into another. So, think about that line where the air meets the water in your glass. That's where the action is.
Now, it's really easy to get refraction mixed up with another light trick called diffraction, so let's clear that up. Diffraction is when light bends as it goes around something, like squeezing through a tiny opening. But refraction, our topic today, is all about light bending because it has gone through a new material. It's a really important difference. All right, so we've established that light bends when it crosses a boundary. But why? I mean, what's actually causing it to change direction?
And here it is, the big secret. The bending happens because light literally changes its speed. Think about it like a car driving on a perfectly smooth road, and then all of a sudden it hits a big patch of mud. It's going to slow down, right? Well, light does pretty much the exact same thing.
You see, light just zips through the air, which is not very dense. But water is way denser. It's just got more stuff packed into it for the light to navigate. So the second that light ray hits the water, it's forced to slow down. And it's that sudden slam on the brakes that causes the ray to pivot and bend. Okay, I know saying it changes speed makes sense, but it can still be a little tough to picture how a change in speed causes a change in direction. Luckily for us, there's a fantastic analogy that makes this crystal clear.
I want you to picture this. You've got a long line of soldiers, all marching perfectly in sync, arm in arm, forming a perfectly straight line. Now, think of that entire line of soldiers as being a single wave of light.
Okay, so first, our soldiers are marching fast on smooth pavement. This is like light traveling through air, but watch what happens when they reach a muddy field at an angle. The soldier on the end hits the mud first and gets slowed way down, but the others are still on the pavement, marching at full speed. This difference forces the entire line of soldiers to pivot, to turn, and that is exactly what happens to a wave of light. The part that hits the water first slows down, causing the whole wave to turn. That's the bend we see.
Now, what's really cool about this is that the bending isn't random at all. Nope, it follows very specific, predictable rules. In fact, there's a precise mathematical law that tells us exactly how much light will bend when it moves between any two materials you can think of. It's called Snell's law. And look, I know the formula might look a little intimidating, but the idea behind it is actually pretty simple. It's basically the official rulebook for refraction. It just means that if we know the angle the light is coming in at, and we know what materials it's passing between, we can predict the exact angle it will bend to, every single time. The most important piece of that puzzle is something called the index of refraction, which we usually just write as n. The easiest way to think about n is as a muddiness score for any material. Air has a really low score, close to 1, but water and glass have higher scores. The higher the n value, the more muddy that material is to light, the more it slows it down, and the more that light is going to bend.
So, for example, if we know the muddiness score for air, which is about 1, and for glass, which is about 1.52, and we know the light hits the glass at a 58-degree angle, we can just plug those numbers right into the formula. We're not going to do the math here, but the point is, this law lets us calculate that new angle with perfect precision. It's the physics that makes all of our optical technology possible.
Okay, bent straws are a fun party trick, but why does any of this really matter? Well, it turns out that understanding and controlling this bending of light is the secret behind some of the most amazing and important things we use every single day. I mean, just think about it for a second.
Refraction is how a prism can split white light into a brilliant rainbow. It's how the lens in a camera focuses light to capture an image. It's how a telescope lets us see galaxies light years away. And it's even how your eyeglasses correct your vision so you can see clearly. It is at the heart of almost everything that has to do with optics.
A prism is just such a perfect example. When white light enters the prism's glass, it refracts, it bends. But the real magic trick happens when it comes out the other side and it's forced to bend again. This double refraction fans the light out, beautifully separating it and revealing that whole spectrum of colors that was hidden inside the white light all along.
But wait, why do the colors separate in the first place? Well, it's because each color of light actually bends at a slightly different angle. And here's a fun little mnemonic to remember the order. Red refracts rotten. That just means that red light bends the least. On the other end of the spectrum, violet light bends the most, which is what spreads the rainbow out for us to see. And this principle is just everywhere. Every single photo you take, every movie you watch, all of it relies on these precisely curved pieces of glass, lenses, that use refraction to bend and focus light into a perfectly clear image. So from the glasses on your face to the giant telescopes exploring the cosmos, refraction is literally how we shape light to see our world and worlds beyond.
So, to wrap all this up, I've got a little thought experiment for you. We know that light slows way down when it goes from air into water. So with that in mind, do you think the light ray bends inward, closer to a straight down path, or does it bend outward, away from it? Think back to our marching soldiers hitting the mud. Which way did their line turn? It's a great little test of everything we just covered about this incredible property of light. Thanks for tuning in.